Okay, here is a set of data on the relationship between candy on Halloween and the number of houses they were visited. I want to use Desmos to create a trendline equation to fit this data. So on Desmos, type that data table in. I went ahead and did that here. You can use the insert key in the top left corner to select a table and then just type in the raw data. Desmos should autofill and create a scatter plot for you. Describe the relationship that you're seeing in the scatter plot. Describe the association. What are you noticing? Positive. So as the number of homes increase, we should see a similar increase in the amount of candy you're going to get, right? The x-axis, our explanatory variable, measures the homes visited. The response variable should be the candy. More homes means more candy. That's pretty obvious. What else? It's a positive direction. How else could you describe the relationship? What's the form? Linear. Linear, right? We're making a trend line, so shouldn't it be a linear relationship? Yeah. How would you describe the strength? Is there a lot of error? No. A lot of outliers? Or is it pretty linear, right? Linear. I'd say pretty linear too. Yeah. Maybe some kids are getting luckier, some kids not so much, but for the most part, I see a general linear relationship in those data points. All right, so here's how to get Desmos to do the lifting for you. On the back wall behind Jaden, we're going to type this in. Slope-intercept form, y equals mx plus b. But we've defined the data set using x1 and y1. Desmos defaults to the x1, y1 in the columns of the table. Instead of equals, Desmos uses this little symbol right here to indicate regression. That's going to be shift and then the button above tab on your keypad, right next to the 1, actually, too. So type that in the next row down, and it's going to create a trend line for us. Y1, that little shift swoosh symbol, I don't know what's that called? Tilde, maybe? I don't know. mx1 plus b.
Ow. Where did that come out?
Wow. It's shift above the tab.
Next to 1. Did you find
it? Yep, just to the left of 1.
I'm supposed to know. Oh, what was I supposed to do?
Did it make what I have up here, Chris?
No.
Don't type in decimal.
You didn't do the little.
Oh, really? We told?
Make sure
Oh.
the points are good.
Don't
type in decimal.
Okay, so here's what we got from Desmos so far. We've got a trend line showing up. That is the line of best fit for our data. I've got some statistics given right here. R squared is the coefficient of determination that was described in the video. The coefficient of determination is a measure for how well the trend line fits the data. What proportion of the total variability is described by the variability in our explanatory variable, the amount of homes visited. You know, closer to 100% or 1, the better it is at fitting the data. Here's your correlation coefficient. Here's R. I've also got the slope and y-intercept we use to write the equation of the trend line down below. The slope is 2.24. The y-intercept is negative 2.05. So I think for the first question on your packet, you have to write the equation of the trend line. And it pretty much gave you everything you need to do that. Write the equation of the regression line. So number 1, y hat equals 2.24 times x, since the slope was about 2.24. What was the y-intercept? It was
Negative 2.05.
Cool, got it. Or you could do the names of the variables to replace x and y. Candy hat, our response variable is the amount of candy that you get. That's equal to 2.24 times the homes you visit minus 2.05. Either way, you might see your equation, whether in terms of x and y or actually using the names of the variables.
Got the cheese frozen. Yeah. Mine was all.
Okay, why don't you guys finish up the rest on that page, front and back. I think question 2 and 3 ask you to give the slope and its interpretation. Same thing on number 3 for the y-intercept. You're going to use the equation of the trend line on the back of page 2
Yes, it is.
to make some predictions. How many pieces of candy should a kid receive if they visit 20 homes? Are you very confident? Number 6 is finding the residual. A child goes out trick-or-treating at 7 homes and receives 18 pieces of candy. What's the residual error based off of the line of regression? Take about 5 or 10 minutes. I'll let you finish up the rest of front and back on page 2. Everyone know what they're doing? Everyone know what they're doing? If you need any help writing down the interpretation for slope and y-intercept, I've left kind of these general statements on the back wall here for you to use. Interpret in context for homes and candy.
So how do you do number 4?
For 4, what's it asking?
Which is on the variation of gain with the.
So that statement should lead you to what? The percent of variability in our response variable in the amount of candy that's explained by the variability in our explanatory variable, not the number of homes visited. That's just asking you to write down the coefficient of determination.
Oh.
So what's your R squared value that you got in decimals?
Put 760.
So 76.13%.
Good job, Nick.
76.13% of the variability in the amount of candy collected is explained by the total variability and the number of homes you visit. That was kind of what we saw on that video.
Yeah.
As an explanation of what R squared means and where it comes from.
Yeah.
What percent of the variation in candy is explained by the variation in the number of homes visited? That's just asking them. What's the R squared value? Okay? The percent of variability in the candy that you're getting, that can be explained by the total variability and the number of homes visited. That's how we interpret R squared. So what's the R squared value that you're pulling off of decimals? Yep. 66.3%. We're going to ask you about that. Okay?
X plus.
The closer R squared is to 1, the better the line is describing the relationship. Make sense? That's kind of what we saw as a background on that video, right? Where R squared comes from, what does it mean, how do we use it, all that good stuff.
That's what piece of candy did you get?
Do I feel confident?
Yeah, because it's pretty strong.
Okay, but now hang on a second.
Hang on a second.
Look at your scatter plot. Look at your data.
Yeah.
You have data that goes all the way up to 20.
Oh, no.
No. So this is an example of what's called extrapolation. you're making predictions beyond the range of the data that you collect. Now, typically statisticians think extrapolation is kind of dangerous because trends can change, right? I don't have data that's going to reflect how many candy I should get based off of 20 homes. I might be more confident in predictions about like 6 or 7 homes because that's within the range of the data that I was given. That's called interpolation.
So you don't feel confident.
I mean, not necessarily. Not as confident if I was thinking about 9 or 10 homes and how many pieces of candy I would get. Because I have data that would describe that amount better than the 20, which is beyond the range of the data that I have.
Okay.
Trends can change. Extrapolation is very dangerous. That'd be like saying, I have the price of a gallon of gas between 1920 and 1950. How much is it today?
Yeah.
Okay, so that's from 100 years ago. I don't know what it's going to look like today.
True.
I'd be leery of using that value based off the regression line using data from so long.
How do you find residential?
Residual. Sorry, I couldn't say it. Residual
Error.
is the error. It's the actual amount of candy that you got minus what you were expected to get based off the number of homes you visited.
So you want to plug in 7 to the next year.
Yep. And then take the difference. If residual is positive, what does that mean in this context?
That,
If the residual is positive, what would that mean about the amount of candy?
More than, wouldn't that be more than
You did pretty well, right? You got more candy than what you were expected to get. If you got a bunch of candy at a couple homes, you got a bunch of. If residual is positive, it means you got more than you would have thought. Because the actual value would have been more than what you were predicted to get.
Oh.
If residual is negative, that means that you actually got less than what you were supposed to.
Yeah. Okay.
So a negative residual means that you got like toothpaste in a couple homes.
Yeah.
And you didn't get as much candy as you should have.
Let's go with the big
Yeah.
one. 2-7.
Oh,
You gotta figure out how much candy you were supposed to get and then take the difference.
Can I take the test I missed last week?
Sure.
Huh?
Zero. Why are you so dumb?
Last time.
I used to, I did put that minus 18.
You'll need Desmos probably, Connor,
Alright, I got it.
for a question on.
Yeah.
Everything else should just be a constant.
Sounds good.
All you need.
After we get this with the tool package.
Oh my
Oh, no,
god.
what's this?
What I missed last week. Was that home being potato?
Okay, let's see if we can't finish this up, guys. Let's talk about your work so far, just to make sure everyone's on the same page. I've kind of helped a few people here. So let's wrap this up to make sure we're all understanding how to create and interpret and use an equation of a trend. Which one of these numbers is the slope?
2.24.
Good. M equals 2.24. What does that mean in context as our rate of change? On average. Per each additional home, we're expected to get another 2.24 pieces of candy on average.
So Thank you.
For each additional house, expected to get 2.24 more candy, more pieces of candy on average. There's some variability. Maybe on one house you did really well, got a couple different pieces of candy, got like 4 or 5 pieces of candy. Maybe you went to a house where you only got 1 piece of candy. There's some variability, but on the average, about 2.24 pieces per house. The y-intercept is the other number, the negative 2.05. What does that mean in context? Somebody else, what does the y-intercept tell us about the houses and the candy?
Oh, if there were 0 homes, then you'd have.
Here's my hand.
negative 2.05.
Thank
pieces of candy.
When you go to no homes, you should get negative 2.05 pieces of candy.
Yeah, I think that should be like a positive though. This is, gonna be candy.
So, right, Isaac, is that very meaningful in context? No. Typically, the y-intercept for most data sets is meaningless. But it is still kind of important to know what it means about a line in general anyway, so. I do give that to you, but I agree. It's kind of on the back. Number 4. What percent of the variation in candy is explained by the variation in the amount of homes visited? This is just asking you to give the R-squared coefficient of determination, which tells us how good our line fits the data. Based off of Desmos, that was, got it. Yep, 76, 13%.
76, 13. Can we? Why did you not say that?
I should.
Okay, last couple. How many pieces of candy should a child receive if they went to 20 homes? Are you very confident in this value? What is this asking you to do? Jack,
Plug 20 in for.
plug 20 in. You made the equation, so now let's use it. What is 2.24 times 20 minus 2.05? 4275? Are you very confident? Look back at your scatter plot. This is a little bit new. I don't know if I've mentioned this since we went over the slides last Friday. Look at your scatter plot. Do I have data that goes that far out to 20 homes? I go up to a maximum number of homes of 12. I'm making a prediction beyond the range of the data that was given to me. I'm using this data from 4 to 12 homes and extrapolating all the way out to 20 homes. Typically, statisticians view extrapolation as kind of dangerous because trends can change, things can happen. Would you use data from 1920 to 1950 on the price of gas and reasonably estimate the price of gas today based off of that?
No.
It's called extrapolation. It's dangerous. Things can happen. Who knows? So I would say no. Extrapolation is dangerous.
No function.
Can you guys stop, please? Thank you. Trends can change over time. If I have data between 4 and 12 homes, I'd feel much more confident in the prediction of how much candy I might get from like 7 houses or 9 houses. Not for like 20 homes or 50 homes. Because I'm making predictions beyond the data that I've collected. Beyond the data that was given to me. It's called extrapolation. Kind of wary of that. All right, number 6, this has got a couple different parts to it, a few different steps to solve. It's asking about the residual. The residual is the difference between the candy we got and the candy we were expected to get. What would a positive residual tell us in that case, in context? What would that mean?
Yeah, more candy.
More than I would have thought, did pretty well. A negative residual would mean less. I didn't do so hot. Went to homes that gave out less candy than I would have expected. So this kid went out trick-or-treating and got 7 houses and got 18 pieces of candy. What do I have to do first before I can find the residual? This is how much candy they actually got. What do I have to know first before I can find the residual? The predicted amount. How much should they have gotten? How do I do that? So let's just use the equation to find that prediction for the amount of candy from 7 homes. Let's take 2.24 times 7. I have much more confidence in this prediction because this is within the range of data that I was given. This is interpolation. Minus 2.05. 1363. So they should have gotten 1363 pieces of candy, but they actually got 18. So the residual error is what minus what? Order matters. Good. Nora says take 18 minus 13.63. They did better than was previously thought. So my residual difference is 437. I think I forgot to mention this. Can I go back to Desmos here for a minute? Were there any questions on that so far? Forgot to mention something off of Desmos that it can do for you. If you have Desmos pulled up with that data on candy and homes, do you see there's a button right here that says residuals? Desmos will make the residual plot for you and calculate the residuals in that last column to the right here in red. This person went to 4 houses and got 10 pieces of candy. Is their residual going to be positive or negative? Is this point right here going to have a positive or a negative residual? Positive. Because they did this much better than they would have thought. They should have gotten about 7 pieces of candy. They got 10. That difference, the residual error, is about 3.07. And they plotted that here as 3 units above the x-axis.
Hey, I know, no.
Positive or negative residual. This point, for 6 pieces of candy, positive or negative residual?
Negative.
Negative. They should have gotten about, I don't know, 11 or 12 pieces of candy. They only got 8. So they've taken this residual difference and plotted it down below on the x-axis. They got 8 pieces of candy. They got 3.4 pieces less than they would have gotten. They should have gotten.
Silly guys.
Desmos can do the residuals for you with that residual button that you're seeing right there on Desmos. Cool, cool, cool. We'll do some more practice with this tomorrow. I just wanted to show you how to use Desmos to do trend lines for you today. Let Desmos do all the work for you. And some more practice with interpreting and using your trend line that you're given.